Right, good morning, grade 11s. I hope that you all are well. Miss Janssen let me know that she did drawing exponential graphs and finding the equation of exponential graphs with you guys yesterday, which is excellent. That means that you have now done all the different types of graphs that you need to do in grade 11, as well as how to find those equations. Now, I know that you gave you some homework. I don't have a textbook here at home with me at the moment, so I was unable to do that homework, but I will get a picture from one of my colleagues and I will do that over the weekend so we can mark that on Monday. What we do now need to get into is actually the most important part of functions, and that is graph interpretation. These are often the types of questions that will primarily be in your exams. Even in your matric final exams, they ask these types of questions more often than drawing a graph. All right, there might be one question on drawing a graph, but then 7, 8 questions on interpretation. So we do need to go quite deeply into that. I'm going to write down a note on some of the common interpretations, and then I'm going to direct your attention to a document that is on the Zero Rated server that I want you guys to copy down the examples in your books. And then that will be it. I'm not going to give you other homework for the weekend. On Monday, I will be back at school and we are going to work probably Monday, Tuesday, quite hard on mixed graph questions, perhaps even Wednesday. We'll see how it goes. I'm also going to hand your tests back on Monday. So we'll probably use Monday, Tuesday, Wednesday just to finish up graphs. And guys, like I said before, graphs are very important in matric. So the work that we're doing now is actually setting us up for next year, because next year I'm going to teach you to draw one new graph, which is a cubic graph. And we're going to do inverse graphs, which is also something new. But apart from that, all the questions that you'll get in matric are these types of questions. Okay, so it's very important. I know you guys are tired. I know you would rather be doing revision for the exams, but we have to do this work properly. Okay. All right, so graph interpretation. You did some of these things last year in grade 10. I remember doing it with my class, but if I remember correctly, it was also at the end of a term or something. It was like the end of term 3 or something. So it was quite rushed. It felt quite rushed to me. So the first type of interpretation here, I'm not sure Ms. Janssen might have discussed these things with you already, but I'm just going to go over it again. So if you're asked for the domain of a graph, this is the set of all x values covered by the graph. Okay, now when you're writing your answer, you'll say x is an element of, and then, yeah, it depends on the situation. You can either use round brackets or square brackets. So you'll put your values. We'll look at an example now, or you can write it as a value and then smaller than or equal to, and then you have your x and then your other value. I'll just do a smaller than or equal to here as well. It depends on the type of graph that we're looking at. Okay. So you can decide whether you want to use interval notation, is what we call this. Or if you want to use inequality notation. All right, in grade 10, we used to specify which one you had to use just because it was new work in grade 10, the different types of notations. But in grade 11 and grade 12, that's up to you. You can decide which notation you are more comfortable with. Just see if I switch this light on, if it's better. Yeah, okay, I'll leave it like that for now. Okay, so that's the domain. The second one is the range. And the range is just the set of all y values covered by the graph. Okay, so in the same way, you can write your answer in inequality notation or in, sorry, in interval notation is that one, or in inequality notation. Right, but you have to remember, if they're asking for domain, it's X. If they're asking for range, it's Y. The way that I remembered it when I was at school was that D comes before R in the alphabet and X comes before Y. So X goes with domain and range with Y. But I suppose, yeah, they're not too difficult to remember. Okay, so those are the first two things. And that's usually a 1-2 mark question in a test where they just ask you what is the domain of this graph and you have to state it. And that's normally 1 mark. If they're asking for the range, it would be 2 marks as well. 2 marks for, yeah, domain and range. And it also depends on the how complicated it is. So the domain of a parabola is less complicated than the domain of a hyperbola, for example. Yeah, we'll look at some examples in the document that I'm going to show you guys just now. Okay, the third thing is that there are various transformations that we need to talk about. Now, the transformations are transformations that you learned in grade 9, but we have to apply them to graphs, to all types of graphs, straight lines, parabolas, hyperbolas, exponential graphs. All right, you need to be able to do these transformations on all of your graphs. Now, guys, I just want us to write down the standard forms that we have. We have y equals mx plus c. We have y equals, and now for this one, I'm just going to write down 2 of the standard forms. That's the standard form of a parabola, but then we also have y equals a, x minus p squared plus q. Or let's just write the third one. I said at first I wasn't going to, but let's just be, you know, let's write down the correct note, the full note, and that is x-intercept form. All right, then we also have y equals a over x minus p plus q. And then we have y equals a times b to the x minus p plus q. Right, now in all of these equations, I want you guys to notice that the last term, right, the plus c here, that's the y-intercept, plus q, that gives you your horizontal asymptote, plus c, that's also the y-intercept. All right, the plus q here is the y value of your turning point. Plus q is also your horizontal asymptote. Guys, all of these final terms in these standard forms represent an upwards shift. All right, it's always a constant term. It's always the one that has no variable attached to it. If we look at all of these formulas, the C or the Q values are always the values that are constant terms. So the constant term represents an upwards or downwards shift. So now if they've given you the equation of a graph and they are saying that this graph is now shifting 2 units up, give the equation of the new graph. You are going to add 2 to whatever your constant term was. All right, so that is the first one, the easiest one, I suppose. A shift up or down. Right, so when you have a shift up or down, you are going to add or subtract the number of units. So they'll tell you it's shifting up by 2 units or shifting down by 7 units. Okay, they'll have to be specific about that. So you're going to add or subtract the number of units from the constant term. Okay, for example, sorry that this thing keeps jumping. For For example, y equals 3 times 2 to the power of x minus 1 is shifted 4 units up. Right? Then what is the new equation? If this graph is shifted 4 units up, then the equation becomes y equals 3 times 2 to the x minus 1 plus 4. You literally are just adding 4. And guys, it is adding 4 to the constant term, but you're actually adding 4 to the whole equation, right? Because the whole graph is shifting 1 unit up. Oh, sorry, 4 units up. So if you're looking at this, you can actually also just say that in fact, we are adding or subtracting the number of units from the whole graph, from the entire equation. But because when you're shifting up or down, you're adding or subtracting a number, so that will be also a constant. So the constant term and the number of units will always be like terms. So those are the ones that you are effectively going to add or subtract. All right, so here you add or subtract the number of units from the constant term, which is basically the whole equation. You're adding or subtracting. In this case, we're adding 4 units to the whole equation. But like I said, because these are now like terms, we're actually adding it to the constant term. All right, the term that has an x in it is not actually going to change. We can't add the 4 to that term because these are not like terms. Okay, so the equation actually is 3 times 2 to the power of x plus 3. Okay, and it will work like that for all of the graphs. If they've given you a parabola in this form, you're going to work with this form and you're going to add a 4. If they've given you the parabola in this form, you're going to work with this form and you're going to add a 4. All right, so they've given you this, you'll add a 4. If they've given you this, you'll just add 4. Okay, so the up or down shift is actually the easier one to do, the easiest one of all the transformations. Okay, now a shift to the left or right. Now, guys, if we are looking at our graphs here, you can't really see it that nicely with the straight line. But when we are looking at our graphs, a left or right shift is always shown by what happens to the x, right? The x minus p, in fact. When you are shifting, say you had just ax squared plus q, right? And that was the equation of a parabola. If you now shift that parabola 2 units to the right, it becomes ax minus 2 squared plus q. If you're shifting that parabola 1 unit to the left, it becomes ax plus 1 squared plus q. If you have a hyperbola, if you just had a over x plus q, that's the equation of a hyperbola. Now, if you shift that whole hyperbola 2 units to the left, it will become x plus 2. Same with the exponential graph, which is what you did yesterday. If you're shifting that whole graph 2 units to the left, it will become x plus 2. If you're shifting it 2 units to the right, it becomes x minus 2. So in the same way that here we added or subtracted the number of units just to the equation, to the constant term, if our graph is now shifting to the left or the right, we are going to add or subtract the number of units from x in our equation. All right, and even though you can't see it so nicely with this straight line graph or in this form or even there, I'll do an example with that type of equation now. That is what you're going to do. Whenever you're shifting to the left or to the right, you are going to add or subtract the number of units that you're shifting. Change the sign. Remember, the sign always has to be different with our left or right shift. And then do that to the x. All right, and then we'll simplify it. So shift left or right. Sorry. You're going to add or subtract the number of units from x in the equation. You might have more than one x in the equation, in which case you're just going to add or subtract it from both of those x's. Okay, so let's do one that is maybe a bit easier to recognize first. So if you have the equation y equals 1 over x plus 2, and this graph is not f, sorry. is shifted 3 units to the left. All right, so we now need to add or subtract 3 to or from x. We need to figure out, are we going to add 3? Are we going to subtract? Now, guys, if you are moving to the left, that is in the negative direction. So that means that we're going to add 3. All right, so when we shift to the left, remember that the sign that you have is always the opposite sign to what the actual direction is. So when we're shifting to the left, we're going to add 3. So the equation then is just going to become 1 over x plus 3 plus 2. Okay, that is what you would have to do in that case. What if you have y equals 2 to the x plus 1 minus 4, and that graph is now shifted 2 units to the right. All right, so if it's shifted 2 units to the right, we're going to have to add or subtract 2. But when we're moving to the right, we're going to have to, remember, moving in the right is in the positive direction, so we're going to have to minus 2. So minus 2 or subtract 2. Okay, so now what I want you guys to notice is that there is already a plus 1 there. Okay, so that's slightly different from this one. If we have 2 to the x, now what must I do to my x when I'm shifting 2 units to the right? I have to minus 2. So x minus 2. So x becomes x minus 2, but there was already a plus 1 there. We can't discard that plus 1. And we also can't discard that minus 4. That also has to stay there. All right, so now I must just actually simplify that. So I'm going to have 2 to the power of what's negative 2 plus 1, negative 1. So x minus 1 minus 4. Now, guys, let's just quickly think. If we compare these two graphs, right? What was an x plus 1? This means that this was the exponential graph shifted 1 unit to the left. Now, if I shift this 2 units to the right, does it make sense that it is now at 1, at positive 1 if I'm shifting? All right, so whenever you have this kind of scenario here, that you already had a plus 1 by your x, you must still subtract 2 from x now because you're moving 2 units to the right, but that plus 1 still has to stay there, and then you're going to simplify it. Okay, I quickly want to do an example with a parabola that is in this form, just so that you can see how we would do that. I think it is one of the examples in the note, that the examples that I want you to copy down. All right, so just the last example, if y equals x squared plus x minus 1 is shifted 1 unit to the right. Okay, now this is a case that I was mentioning before, that we have 2 x's in this equation. All right, so we're going to have to do the shift to both of those x terms. So if you're shifting 1 unit, we're going to have to add or subtract 1. Let's see, when we're moving to the right, that is in the positive direction, meaning that we have to subtract 1. So we're going to turn each of these x's into x minus 1. So my x squared is going to become x minus 1 squared. Plus this x is going to become x minus 1, you don't really need a bracket for that, but if it was like a 2x, for example, you would have to put the 2 outside and you would need a bracket for that. And then minus 1. Okay, then from there, you would just have to square this bracket out. So I'm just going to do it quickly. It would give you minus 2x plus 1. Okay, you can write x minus 1, and then FOIL them out. This is what you would get. Plus x minus 1 minus 1. And now if I simplify that, I'm going to get the equation of the new parabola. So negative 2x plus x is negative x. 1 minus 1 is 0, and then minus 1. Okay, so this is the equation of the parabola that you get when you shift this one unit to the right. Okay, so like I said, you apply the x shift to both of the x's that you have in the equation. Okay, so that is a shift to the left or the right. Then we can do some reflections. So reflection in the x-axis. Right now, this might look foreign to you. You might remember this from grade 9, that when you reflect something in the x-axis, the x value will stay the same, but the y value will change its sign. Right, so I'll just draw a quick diagram here. If you have a little Cartesian plane over here, right, that's the y-axis, this is the x-axis. If you have the point, let's say this is the point 3, 1, and you now reflect that point in the x-axis, that basically means that you're going to flip it over the x-axis. You will get this point here, which, do we notice, still has an x value of 3, but this one will now have a y value of negative 1. Now we apply what will happen to a point to the actual equation, because guys, if you have a graph and you reflect the whole graph in the x-axis, remember a graph consists of infinite points, basically an infinite number of points that have been joined together. We only plot a few of them, enough of them to get an accurate kind of shape representation of the graph, but in fact a graph consists of millions of points. All right, at every single point on that graph, or every single, everywhere on that graph, we can plot a point. We can identify a point. Now, when you reflect the graph in the x-axis, this will happen to every single point. Every single point will keep its x value and will change the sign of its y value. So this is then what we then actually do to the equation as well. All right, instead of just doing it to every single point, we are going to do this in the equation. So in your equation, your x is going to stay x, but whatever your y was is going to change its sign. All right, so the y in the equation changes to or becomes negative y. And that is what you do when you reflect in the x-axis. For example, if they're telling you y equals 2x minus 1 squared is reflected in the x-axis, and they're wanting the new equation. Now you need to remember, in the x-axis, y changes its sign. So y is going to become negative y equals 2x minus 1 squared. You're not allowed to leave it like that though, all right? When you are writing the equation of a graph, you always have to have y, not negative y. So this is negative 1. All I'm going to do is I'm going to move that minus over to the other side. So this equation is in fact negative 2 bracket x minus 1 squared. And guys, if you are looking at these two equations, right, y equals 2 bracket x minus 1 squared, This is the equation of a parabola. Because my a value is positive, this is an upwards facing parabola with a turning point of 1, 0. All right, because my p value is 1, my q value is 0. So that turning point there is the point 1, 0. Now, if you take this graph and you reflect it in the x-axis, it's going to flip. It's going to change from being an upwards facing parabola to being a downwards facing parabola. Now, guys, the point 1, 0 is on the x-axis. All right, this is an x-intercept. Point 1, 0 is on the x-axis. So if you have a point, let me show you here. If you have this point 1, 0, right, and you now reflect this point in the x-axis, it's on the x-axis, so it's going to stay that point. All right, you can't flip that point over the axis if it is already on the axis. So that point will stay. So we have this parabola. Just see if you can visualize it there. All right. The y-intercept, I'm not sure what that is now. Let's see. 2 times 0. Okay, the y-intercept will be 2. So I can just draw. Yeah, that's not to scale at all. All right, sorry. But that will be, that's definitely not to scale. Sorry. That's supposed to be a 2. But it doesn't matter. All I'm trying to show you is the new parabola that you'll get. Okay, so ignore that. It was supposed to be much higher. But now if you take this parabola and you flip it over the x-axis, you're still going to have that point, but it is just going to be a downwards facing parabola, which is what we have here. You have the same values, the same turning point. Do you see that? You still have the turning point of 1, 0, but now your a value is negative. So now it is a downwards facing parabola with the same turning point. Okay, so that is how we do reflection in the x-axis. It's the same method for all of the graphs. If you reflect a graph in the x-axis, y is going to become negative y, and then you're going to move that negative y to the other side, negative 1. Now, guys, if you had multiple terms, you would have to do that for all of the terms. So if you had, for example, y equals 1 over x minus 3, and that graph is now reflected in the x-axis. In the x-axis, so y changes its sign, so this becomes negative y equal to 1 over x minus 3. Now, when you move this negative 1 to the other side, you're going to have to, you are essentially actually dividing through by negative 1 to get rid of the negative 1 in front of the y. And remember, when you divide through by negative 1, you're dividing every single term by negative 1. So this becomes positive y. This is becoming negative 1 over x. And this negative 3 is going to become positive 3. All right, you have to change the signs of all of the terms in the equation. All right, reflection in the x-axis, done. Like I said, guys, we are going to do loads more of these examples next week. So if you are a bit confused, this is just the summary, okay? Reflection in the y-axis, we are still going to practice these. Now, when you reflect in the y-axis, then x changes its sign and y stays the same. All right, I can show you again quickly on a Cartesian plane. Oh, I forgot to put my 0 there. Let's put the 0 there. Okay, this is a bit of a wonky Cartesian plane. Sorry about that. All right, if we now have the same point, well, let's say it's 3, 2 in this case. Sorry about the noise outside. So we have the point 3, 2. Sorry, I'm just going to close the door quickly. Sorry about that, it's the neighbors. Okay, so you have the point 3, 2. This is now reflected in the y-axis. So now you flip it over the y-axis and it will be there somewhere. That's probably not very accurate, okay, but I'm trying my best. And now that will be the point. If we're looking at this, if this is +3, that has to be -3, but it still has the same y value. All right, now like I said before, this will happen to every single point on the graph. If you have a graph and you're reflecting the whole graph in the y-axis, every single point on that graph will change the sign of its x value. So we are just going to do that in the actual equation. So all of the x terms, let's say the x's, I don't know, that doesn't really sound right, but you know what I mean. I'm saying x's because often there will be more than one x in an equation. So the x's in the equation change to -x, and then you'll have to simplify. So let's do an example so that you can see. If you have y equals x² plus 2x minus 3, and that graph is now reflected in the y-axis. Now you need to remember, when you reflect something in the y-axis, the change of the sign of change of, oh my goodness, sorry. When you reflect something in the y-axis, the sign of x will change. So y becomes -x² plus 2 times -x minus 3. All right, so instead of x², we now change that to -x². Note the brackets, guys, that's important. We'll talk about that now. What's -x times -x? Still +x², but 2 times -x is now -x minus 3. Now this is saying that if this is the original graph, it's reflected in the y-axis, it now becomes this graph. Now guys, remember, if you reflect in the x-axis, then this will have to go from being +x², which is an upwards facing parabola, to being -x², which is a downwards facing parabola. Now I'm doing this reflection, right? I'm not actually reflecting it, flipping the shape of the graph. I'm just flipping almost where it is, the position of the graph. All right. So this is important, guys. If you're starting with a +x² and you're reflecting in the y-axis, it's not going to turn into -x². Okay, it's because it's going to do that. It's not going to do that flip. So it's not going to change its shape in terms of the sign. It's going to change its position, actually. All right, so that is important there. Let's look at another one quickly. Let's do an exponential graph quickly. These ones can become quite tricky. So if we have y equals 3 to the x plus 1 minus 2, and that is reflected in the y-axis. All right, now we know when you reflect in the y-axis, x changes its sign. So this is going to become y equals 3 to the -x plus 1 minus 2. But guys, unfortunately, you can't leave it like that, okay? Because standard form of an exponential graph is x minus p, not -x. So we need to get rid of that negative that's in front of that 3. So we're going to do this. I'm going to take out a common factor of -1. Right? Look at what I'm doing. I'm taking out a common factor of -1. So I say -x divided by -1 is x, and 1 divided by -1 is -1. All right. Now this, we also can't leave it like this, guys. We can't have a negative and then the bracket. Do you guys remember from grade 9? You did this the first time. Like 2 to the -x is equal to 1 over 2 to the x. Maybe if that's too much for you, 2 to the -1 is equal to 1/2. Do you remember that? So then we could say 2 to the negative 2 is 1 over 2 squared. Whenever you have a negative exponent, you just move the whole base of that exponent to the bottom of the fraction, and then you change the sign of the exponent. All right, so we're going to do the same thing here, but what I'm going to do is, this is essentially 3 to the negative 1, right? Because that is a negative 1. Now, what is 3 to the negative 1? 3 to the negative 1 is actually a third. So I'm going to write it like that, a third, because 3 to the negative 1 is a third to the power of x minus 1 minus 2. Okay, now, yesterday, when you did exponential graphs, I'm sure Ms. Jansen spoke to you about the effect that your b value has on the shape of your graph, because a in this case is just 1. B, remember, is always the base of the exponent. Now, if we're looking at this one, b is bigger than 1, meaning that it is an increasing graph. Now, if you take an increasing graph, right, and you reflect it like that, isn't it going to become decreasing? Which you also should have discussed yesterday. If your b value is between 0 and 1, if it's a fraction essentially, then you're going to have a decreasing graph. So that is essentially what happens when you reflect an exponential graph in the y-axis. It changes from being increasing to decreasing, or it changes from being, if it was like this, it would change from being decreasing to increasing. Okay, and we see that with the actual value of the b value. But guys, in the first place, you change the sign of x, then you take that out as a common factor, and then whatever you have here in the front, you just need to rewrite that so that it doesn't have a negative exponent. So 3 to the negative 1, you do need to be able to do this, is equal to a half. If you are a bit nervous about that, Mr. Calculator to the rescue. There we go. All right. So if you can't do that in your head, you can use the calculator. That's also fine. All right, guys, those are all the transformations that you need to know in grade 11. In grade 12, we teach you one new one, which we will get to next year. But these are all the transformations that you need to be able to do. And like we discussed right at the beginning, you need to be able to write the domain and range of a function. Now, I just want to show you this document quickly. If you go to the Google Drive, or the Google Classroom, rather, if you go to the Google Classroom page, the grade Google Classroom page, if you go to Functions Notes, click on the link, there will be, I think this is document, I'll check for you now. I think this is document 4, all right? Documents 5 and 6, that's a worksheet and a memo. So document 4 is all of these types of questions. Now, guys, we haven't discussed this, all right? So I don't want you to look at number 1 for now. We'll talk about these on Monday. What I do want you to do is to go through number 2. We'll also talk about 3. Okay, actually, we just did an example like number 2. So let's just look at it together. Then you don't have to do it for homework. So, and yeah, numbers 1 and 3, we can look at in class together. So they're saying, consider the function f of x. Remember, f of x is just y equal to x squared minus 8x plus 7. Determine the equation of the graph which this function would represent if a, the graph is moved down 2 units. So we said, what do we do when we move down 2 units? We minus 2 from the equation. So there we see, they have the equation minus 2. There you get the new equation. Okay, easy. That would be a 1-mark question. B, the graph is moved 1 unit to the right. Okay, now we said when we move to the right, we're going to do x minus 1. And like we did in the example, there are 2 x terms here. So that becomes x minus 1 squared, and that also becomes x minus 1. All right, so y equals x minus 1 squared minus 8 times x minus 1 plus 7. Next step is just multiplying it out. So that is what you get when you FOIL out that first bracket squared. There we're multiplying the negative 8 into the bracket, and then we do our plus 7, and then we simplify. Okay, that will be a 2-mark question, I suppose, 1 and then 2 for the final answer. Okay, like I said, guys, we're going to talk about 3 on Monday. 3 is just where you asked to find lengths. Okay, that's another interesting application type question. And then for number 1, you have done these types of questions with trig graphs, but we will do this example in class together on Monday. All right, guys, that means that you have no homework. Please, if you feel like you have fallen behind this week, make sure to catch up over the weekend. If you have not done your exponential graph homework from yesterday, please do it over the weekend. We are going to mark that on Monday, and I really, please, guys, I'm not going to have time to reteach that stuff. You need to make sure that you are caught up on that, because the more time I have to spend on reteaching stuff, the less time we're going to have on revision at the end of next week. Okay, so you have to make sure that you are on track for that. All right, otherwise, guys, have a lovely weekend. Remember, if you want your test mark, you can email me. Oh, sorry, you can email me. I have sent most test marks out, I think. Probably like half the class have asked me for theirs. So yeah, feel free to do that. Cool. Thank you, guys. Have a lovely weekend.